In my previous video I tried to explain foil, but I couldn't explain foil that much. But yeah, in the previous video I explained why distributive property works for each case. Now let's a little bit warm up. Distribution property states that x times any expression, suppose y plus x equals to xy plus, so what I'm writing, oh yeah, actually xy and x squared, or x times x means x squared, same thing. And the main problem is, one thing distributive property doesn't work here is when you have, instead of this, if you have x plus y plus x times x, then you are stuck in a loop until you transform it into this. Now you tell me why it doesn't work. Yes, it should still work, because yeah, in multiplication order doesn't matter, but still order matters when you try to simplify. This side means x plus y is added, x is added x plus y times, which is completely different from x plus y is added x times. Okay. Forget it now. Yeah, this method. Yeah, what I'm saying, like, you can't further simplify until you apply the FOIL method. Now we blindly apply FOIL method here, that x times y or y times x, whatever we write, and x times x or x squared. Now the main problem is, when you apply the FOIL in this time, or in this style, or in this structure, you're essentially transforming that into x times x plus y plus x, because without that you cannot further, like, simplify this expression. It's a part of simplification, and that's how maths work. It's the logic, it's a common sense, because multiplication means repeated addition, and this side explains what is getting added and which one is getting repeated and how many times it's getting repeated. So this expression means x is getting repeated x plus y times. Okay, but when you, instead of this, when you write like this, x times y, now this side is repeated, y plus x is repeated x times. So we know, so my final conclusion is, a structure of a multiplication depends on its order, not the value. The value stays same, but the structures differs. A very simple example of it is 2 times 3 and 3 times 2. Although they mean completely two different things, but their value is same. 3 times 2 means you add 2 3 times. That means 2 plus 2 plus 2, which is 6. And 2 times 3 means you add 3 2 times. Look, you add 2 3 times, you add 3 2 times. Although we saw that this thing doesn't affect the value, but it affects the structure. They're completely two different meanings. Completely two different meanings than each other, but their values are same. So that's how the distributive property works, because when you have such expression, if this x is not here and this, then you have to turn into x times y plus x, because it doesn't simplify further, because if you add x plus y times, and you again stick to x plus y times x, because that's what it means. Now if you little bit change the structure, now you will get x plus y added x times, which means, of course, now if you add x plus y plus x, or x plus y, whatever you say, y plus x dot 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 x times, now we don't know x is, but one thing we know, x is a finite number, not an infinite number, and x is not equals to 0. So Now in this case, of course, y was added x times and x was also added x times, because you are multiplying means y plus x is added x times. Now if you group the terms, now y was added x times, x was added x times. It's common sense, because y plus, suppose if you have 2 times y plus x, that means y plus y plus x. Now you get 2y 2x, very common sense, because x plus x literally means 2 times x. It's a simplification process. Now we got the point. Now let's us get into the FOIL method problem. So when you do FOIL method, when you have x plus y times a plus b, suppose two variables, now you multiply with this one, then this one, then this one, then this one. But why? That's a very what I'm gonna say, very specific way. But why in this way? It's a very actually a simple way. What we are doing, we're just skipping some steps here. Now let us stop talking about the FOIL method and let us get into the simple method, which is, suppose you have x times x plus y times a plus b. Now when you have that, so now you can write x plus y times a plus x times x plus y times, let us write here, b. Now why this? Because the whole expression this, like it literally means first add x plus y, then multiply with a plus b. Now a plus b is just a plus b. Like this means x plus y, the whole expression is getting added, or sorry, what, multiplied with a plus b. Now as you cannot add a plus b, but we can add the x plus y. Now x plus y is still x plus y, because they're blind numbers or variables. So variables, now you can say that a plus b, but still you have to multiply x plus y with a plus b, so it makes sense. Now a plus b was added x plus y times, and like so if you grouped the terms, x plus y is a finite number, so a was added x plus y times and b was added x plus y times. Now we get x plus y times a plus x plus y times b. Now it won't, but you cannot write it as a times x plus y, because their value is same, but you got x plus y times, a was added x plus y times, but x plus y wasn't added a times. Okay, so now we got here, but we have to transform it into a times x plus y. Why? Because x plus y, because why, because it doesn't simplify further. Because if you try to simplify this, now you can blindly use the, what I'm gonna say, the distributive property, as you know, but it's literally means you are writing a times x plus y, then multiply. Because why? Because it can't be simplified further. You can write x a times x plus y, which means x plus y was added a times. Now if you write x plus y times a, that means, sorry, what I did, oh yeah, x plus y times a. Now it means a was added x plus y times instead of x plus y was added a times. It's really confusing, but it's really easy when you understand. So you have to little bit change the structure, little bit, although they doesn't change the value, but it changes the structure. Now what we write, now we write um, sorry, now we got x. Now we transform x plus y times a into a times x plus y. You have to give brackets, because the literally means bracketed, because when you add x plus y, you just again left with x plus y, and when you add a plus b, you're still left with a plus b, as their blind numbers can't be added normally. They stay as the structure. Now you may call them variables, but I call them variables. Now plus b times a, because x plus y, sorry, it's a mistake. Sometimes it can be really confusing, but it's not really confusing when you think so. So x plus y, now we get what? Now we use the distributive property because x plus y was added a times and x plus y was added b times. Now, so we get ax plus ay plus bx plus by. Now in this case, look, you cannot add the like terms because they're completely two different numbers. Yeah, a plus x and b plus, sorry, a times x and b times x. If it was like 1 times x plus 2 times, if they were numbers, then you can add, but until that you can't add them. Now we got the exactly opposite. What did you do if you use the FOIL method, or sorry, what, yeah, FOIL method in that expression? Now let's understand the FOIL method. What is FOIL method? It simply means when you have x plus y times a plus b, these two expression, it literally means a plus b times x plus y. You just switch their places. How? Now if you distribute a plus b in x plus y, now you get a plus b times x. Now a plus b times y. Always you have to remember that the a plus b will be distributed in the front or the first position, not in the back. You can write in the back, but you again have to make it in the like front. After that you can write into the back. You can skip this step. This is a step. When you have, always remember, when you have a plus b times x, you have to always turn it into x times a plus b, because a plus b times x can, you now, you don't have to always turn, but if you want to like understand, you always have to turn, or you just apply the distributive property. If you didn't know the distributive property, then it couldn't be further simplified, because it literally means x times a plus b. Now it's a x is added a plus, like a plus b times, but when you switch the places, now it x times a plus b, now a plus b is added x times. I think you got it. Now we simplify. Now we turn this thing into, because it can't be simplified further in this method, so we turn this into x times a plus b as y times a plus b. It may seem a little bit confusing, but it's not really that confusing if you think so. A plus b, now you get xa because a was added x times. Now xb again plus ya plus yb. Look, now if you apply the FOIL method in x plus y times a plus b, look, as I explained, what you get, xa plus xb plus ya plus yb. Look, as I explained, it is exactly same. FOIL method literally means x plus, if you have x plus y times a, it literally means saying you to switch their places, a plus b times x plus y. Very simple, very logical. Like, man, it took me a lot of time to understand this thing.